Okay, and then let me just share my desktop here. Okay, can everybody see my desktop there? Anybody? Just let me know if you can see it. Can you guys hear me? Paul, can you still hear me there?
Yes, sir.
Yes, sir.
Okay, I was unaware. I didn't know if anyone could hear me. So just, could you see my screen when I shared it?
Yes, sir.
Okay, let me share it again. Okay, so we're picking up here on lesson 3 on logical operators. And logical operators, now we're going to really start digging into how we run software on these little microprocessors. And for you guys that did robotics with me, sort of through grades 4, 5, and 6, you will have encountered these before. Okay, so you will have seen this before. Okay, so just going through the notes, so they'll say so in previous grades you've encountered relational operators. Okay, so relational operators are things that will relate things together. They include things like less than, greater than, less than or equal to, greater than or equal to, and not equal to. And you will have seen this in normal mathematics before, how you can relate two things together. So the purpose of relational operators is obviously to test whether a given statement is true. So for instance, if you say 5 is greater than or equal to 6, that only has one of two possible answers. It's either it either is true or it is false. Okay, and that's what Boolean logic is all about, and we'll get to that now. And we can also say, for instance, that the word Bob is not equal to the word George. And sorry, excuse me. Which we know that to be true because Bob obviously is not the same as George. Okay, it's spelled completely differently. So with logical operators, okay, we can use what we call logical operators to connect these relational operators that we used before. And we can connect them into sort of more complex statements. And that's what we're going to be doing. So Boolean algebra is named after this guy, George Boole. Okay, you might think to yourself, well, Boolean algebra, you know, it's used extensively in computers, so it was invented when computers were invented, but that is not the case, right? Boolean algebra has been around right from the mid-1800s, way before computers were around. Boolean algebra was around as sort of as a branch of mathematics. And it differs slightly from the normal elementary algebra that you guys are used to, because obviously you guys are used to an infinite number of numbers and all sorts of things, right? So Boolean algebra does not have that. Boolean algebra just has zeros and ones. And you're also in normal algebra that you guys are used to, you're used to addition and multiplication, addition and obviously division and subtraction. And here in Boolean algebra, we don't use that. Okay, so we are using the and, we are using the or, and we are using the not. Okay, so those are our prime operators in Boolean algebra. Okay, so let's pick those off one by one. So let's tackle the and operator first. Okay, the and operator. Okay, so the AND operator is a Boolean operator that's used to perform logical conjunction between two expressions. So we would say expression A and expression B. Okay. Now, don't worry about the word conjunction, fancy terms. No one's going to ask you that in a test. But this is important, this piece here. Okay, so an AND operator, the result of an AND operation is true only if both of its expressions, the parts on the left and the right hand side of the AND, if they both have to be true. Okay, so the result of the AND is true if both operands are true. And the word kind of gives it away. It says AND. Okay, so this expression 1 and expression 2 have to be true to get a true result. And in many programming languages, the AND operator is represented by these 2 ampersand signs. Okay, definitely looks like that in Java, and many programming languages look like that, or they write the word AND, one of the two. Okay, so that's how the AND operator is implemented. Now, this here is what they call the truth table. Okay, this shows you the range of possibilities for the first expression, okay, the left-hand side. And this is the range of possibilities for the right-hand side. Because we have 2 possible options, or because we've got 2 expressions, there are 4 possibilities of inputs. Okay, either they can both be false, both be 0, or expression A is false, expression B is true, or expression A is true and B is false, or A is true and B is true. So there is 2 to the power of however many expressions we've got. That's how many options we've got. And we saw that when we were doing binary numbers. You could see if we had 2 binary digits, there were 4 possibilities there. If there are 3 binary digits, there are 8 possibilities. Be the same here. If we had expression C, there would be 8 possibilities, not 4. And you can see here, like we said, the output can only be true. Okay, so we get this 1 here. So we're only going to get a true output if both inputs are true. Any other time, the output is false. So here's an example. Okay, so you can see here, expression A, we are saying 5 is greater than or equal to 7. And expression B is Bob equals George. So let's have a look at that. So we say to ourselves, is 5 greater than or equal to 7? Obviously not. Okay, so the answer to the left-hand side here, this expression on the left, is false. Okay, so we've got a false over here. And here, is Bob equal to George? Quite clearly not. They are 2 different words. So we've got false and false. And over here, we can see that if we've got a false and a false, the output is false. Okay, we know that for an AND, both inputs have to be true. That is why we got a false here, because that is false and that is false. So this here is false. Let's try this other example. So we're saying here that Alice is less than Bob. Okay, now this is important. The answer to this is yes, true, because a computer treats capital A as less than capital B. Okay, each letter in the alphabet gets given a number. And the number for capital A is less than the number for capital B. So a computer can do this. It can evaluate this. And it does it all the time when we do things like sorting and searching. It has to look for this sort of thing. So the answer to this side here, Alice is less than Bob, is true. Okay, a computer is going to treat that as true. And here we are saying that Alice is less than George. That is also going to be true because obviously capital A is going to be the least number in the alphabet. Okay, so it's going to be less than capital G. So Alice is also less than George. So we know this is true and this is true. And we know that for an AND, if we've got 2 trues, the output is true. We can see it here. True and true gives us a true. Okay, so that is the AND. So let's have a look at the OR operator. So the OR operator, okay, is a Boolean operator that's used to perform logical disjunction. Okay, fancy word once again, don't worry about that. Now the OR is slightly different to the AND in that it'll be true if either or both of its operands are true, okay, or false otherwise. And in computer languages, we type OR as 2 vertical bars. So here's the truth table for it. Okay, you remember with AND, we only had a 1 at the bottom. We needed 2 truths to get a true for an AND. But for an OR is different. Any one, okay, any true on the left or the right or both, it doesn't matter. The word OR gives it away. Left or right, okay, if either one of those is true or both, it doesn't matter, you will get true. Okay, so you can see we got 3 trues aside and only 1 false. So that's the truth table for an OR. Okay, let's have a look at these examples. Same sort of thing. Okay, is 5 greater than or equal to 7? No, we know that is false. Okay, does Bob equal George? Nope, we know that is false as well. These words are completely different. Okay, capital B and capital G, they are not equal. Okay, so we got false or false. We get a false. Okay, we know that for OR we need at least 1 true for it to be true. So let's have a look at this one. Alice is less than Bob. Yes, we know that is true. Okay, I said to you, capital A is less than capital B. So as soon as we've got a true here, we don't even have to look at this. Okay, as soon as we've got a true, we know that just 1 true is enough to give us a true over here. Okay, so we are saying here, is Alice greater than George? Nope, we know it's false, but it doesn't matter. This true was enough to give us a true output. Okay, any true gives us a true. So that is an OR. Right, the third one we get to, and this is the last one. Okay, there are others. Okay, we just won't do them. We get NAND, we get NOR, and we get exclusive OR. There are other types of operators, but we are not going to do them here in grade 9. So the NOT operator is a Boolean operator that is used to perform a logical negation. It flips it, okay? So the NOT operator gives us a true if its operand is false. So it takes an input and just flips it around. It takes a false and makes it a true, and it takes a true and makes it a false. That's its purpose. And you'll see with NOT, there's only 1 input, not 2. So if the input is false, the output is true. If the input is true, the output is false. So let's have a look at these examples here. 5 greater than or equal to 7. We saw this earlier on. The answer to that obviously is false, okay, because 5 is not greater than or equal to 7. So the answer to that is false, and we know that not false is true. It flips it, okay? So let's look at this one. Bob equals Bob. They are exactly the same. The capital letters are in the same place. The lowercase letters are in the same place. So these 2 words are identical. So that is true. And we know that not true is false. Great. Okay, so those are the 3 operators that we're going to deal with. So let's have a look at what we call precedence. Now, you have seen precedence before in mathematics. Okay, you will have seen it as BODMAS, okay, brackets of division, multiplication, addition, subtraction. That is telling you the order in which you have to evaluate an expression. So if you've got a mathematical expression that's just got a whole lot of pluses and minuses and multiplies and divides, it matters what order you solve that in, okay? And we've got exactly the same thing here with Boolean algebra, okay? So instead of BODMAS, we've got this here, okay? You can call it BNAO if you want to, okay? Brackets, that comes first. That you always do brackets first. That's the highest priority. Then you do any knots, okay? and a not is an exclamation mark. That's how its symbol is. So that comes next. And then you do ands, and then you do ors. Okay, so that's the order of precedence in which you do them. Okay, so and obviously if they join by the same operator, so if you've got something and something and something, you can just solve it from left to right. It's the same as saying this plus this plus this. You just go from left to right. Now, me myself, when I solve these, I tend to add brackets in. Okay, it just makes it easier for my eye what I must do. So let's look at this first example here. We've got A or B and C. Okay. Now, if we look at this, we know that there are, I'm looking on the left-hand side, there are no brackets to begin with. There is no not. Okay, so I don't have to do that. There is an and though. So I've got to do the B and C. I've got to do that first. So I put brackets around that. So I know that I've got to do that first. And once I've done this, then I can OR it afterwards. Okay, so that's how I'm going to do that. I'll do the AND first, and then once I've solved this, I can do the OR. So let's look at this one over here. Okay, a little bit more complex. We've got A and B or C and D. Sorry, excuse me. So we know we got to do AND first. So I put brackets around A and B, and then I put brackets around the C and D. Okay, so I need to do that and that have to be done first. And once I've got the answer for this and I've got the answer for that, then I can OR them together. Okay, let's have a look at the next one here. We've got A and B and C or D. Okay, so it doesn't matter which, I have to do the ANDs first. So I can do A and B, so I put brackets around that. Then once I've solved that, I can do the result of that and the C, because remember, I can just do ANDs from left to right. And once I've got the answer for all of that, I can then OR it with the D. And these will become more apparent to you as we get to the proper examples here. You'll see how these things actually work out. And in this last example, we have to do the not first. Okay, so I put brackets around not A. Then we do the and next. So then I put brackets around that. Okay, so that comes next. And then the or C, that comes last. So let's have a look at these. Okay, so here is a set of exercises that you can try. So what happens here is you get given 5 statements over here. So A is equal to 12 is greater than or equal to 10. Okay, so you have to say to yourself, okay, is 12 greater than or equal to 10? Obviously, yes, it is. Okay, so A is true. B is Isabel greater than Jennifer. Okay, we covered that earlier on. You can work that one out. C is length 100 equals 11. Now I'll show you how to do this one. Okay, the length, okay, length is a method in Java that will tell me what is the length of this string. Okay, this string of text here, what is the length of that, including the space bar, okay, not including the inverted commas. So what is how many letters are in there, including the space bar, okay, and then you're going to compare that to 11. So if that is 11 characters, then obviously C is true. If it's not 11 characters, then C is false. D is true. Okay, that's an easy one. Then we're saying here that 10 times 5, 50 is less than equal to 45. We know that's not true. That's false. Okay, so you've now got, you know now what A, B, C, D, and E are, which is true and which is false. So once you know that, you can now start solving these. Okay, so we know that A is true. Okay, so we got that, and then you have to see what is B, and then work that out. And then once you got that answer, you AND it with C. So that is how that goes. Okay, and there are a set of expressions. These are these expressions you can do. I will put up a quiz in Teams so you can actually enter your answers in for that. Okay, let me just stop sharing my screen here.